Now that we've seen all the features that can occur on a rational function, it's really important that we also understand how to solve equations involving rational functions. Okay, so as with every other kind of equation we've had in this course, it is entirely possible to solve those equations graphically. Okay, so we'll keep that in mind. That's kind of our backup plan. But if we need to find exact answers, or if we're told to do it by hand, we need to make sure we know how to do that algebraically as well. Now it turns out these steps will be just like how we solved equations with fractions earlier in the course. So we're going to start by multiplying both sides of the equation by the least common denominator of those fractions. Or, if you prefer, just multiply by all the denominators together, and that'll work as well. Then we're going to solve that resulting equation like we would normally. Okay, so let's try this out on a quick example. Also, as a third step, just like we did in logarithmic equations, we do want to double check at the end that we don't have any extraneous solutions. So let's think here. Step 1, what is the least common denominator of all those denominators? Well, there's only one denominator here, so I'm just going to multiply the whole equation by x minus 1. Right, that's the left side and the right side. So I've got x minus 1 times x squared. I've got x minus 1 times this thing. I've got x minus 1 times x. I've got x minus 1 times x cubed over x minus 1. Let's see what all that simplifies to. Okay, so if I distribute here, x cubed minus x squared, these guys cancel out, so that's plus x. Now, if I distribute here, I've got x squared minus x. These guys cancel out, and I just get x cubed. So every single term in there got multiplied by that least common denominator, which was, in this case, just x minus 1. So let's get everything over to one side of the equation. So I'll subtract x cubed from both sides. Not so bad. Let's add x squared to both sides. And then let's subtract x from both sides. Well, I can solve that. Okay, so this is 2x squared minus 2x equals 0. I'm just going to solve this the way I normally would. So I'll factor out a 2 from the right side. And then I'll factor out an x from the right side. Right, or I could have just factored out 2x from the beginning. So I've got two factors. Let's set each one equal to 0 and solve. I've got x equals 0. I've got x equals 1. So those are my two solutions, x equals 0 and x equals 1. But let's double check, make sure they're not extraneous. So go all the way back to the original problem and plug those guys in. Let's start with x equals 0. So let's see, that would be 0 squared plus 0 over negative 1 equals 0 plus 0 cubed over negative 1. So let's see, 0 equals 0. That one works. Let's try x equals 1. So all the way back to the original. 1 squared plus 1 over 1 minus 1 equals... Well, hold on. Before I go any further, I've got 1 over 0. I can't even do that. Dividing by 0 is not allowed. So it looked like that was a solution, but as it turns out, that is an extraneous solution, just like we sometimes saw with logarithmic equations. So it looked like I would have two solutions, but apparently the only one is x equals 0. Okay, so a follow-up I want to do here. It's really important that we also think about how we could solve this graphically. So let's try this with our tried and true intersection method. So going in the calculator, okay, y equals, clear things out here. So let's try our first equation, that's the left side, x squared plus x over x minus 1. And the right side is x plus x cubed over x minus 1. Oops, helps if I type it correctly. X plus x cubed, there we go, over x minus 1. And let's put this in zoom standard and see if we can find those intersection points of the graphs. So here comes my first graph in blue. Very strange looking function. Here comes my second graph in red. I'm hoping I can find the intersections of these. Where is that red graph? There it is. Alright, I see one intersection point and some weirdness going on there. So one of the disadvantages to trying to solve these guys graphically is it might take a lot of work to find where those guys intersect. Like, did they intersect off the top of the screen? I'm not sure. Did they intersect off the bottom of the screen? Unclear. Okay, so in a lot of ways it's actually easier to solve these guys algebraically, but I can at least confirm that I've got that solution right there. So I'm going to use the intersection method, so second calc, pick that intersect feature, number 5. Okay, something from the blue curve, something from the red curve. Here's my guess. And my calculator's going to confirm, yep, that's really at the point x equals 0. Okay. So whether we do this algebraically, whether we do it graphically, we'll get the same answer, x equals 0. But I will go ahead and advocate it tends to be a bit easier to go ahead and just solve these guys algebraically, because the graphs can be very strange and very difficult to try to find the intersection points if you're just looking at the picture.